Okay, in this video, we're going to do some more review with how you factor general trinomials. So this quadratic expression is called a general trinomial because it has three terms. And I refer to it as a general trinomial. And notice right away that the first term, the first coefficient on x squared is not 1. If this were just a 1x squared, then it's what I call a simple trinomial. And you can find two numbers that multiply to 4 and add to 9, and you're done. So the first thing I'll point out about factoring is that what we really care about is getting the right answer, because we know when we have the right answer because we can always check by expanding. So however you get that final answer is fine. Often you can guess and check. And this one you can actually guess and check and get the right answer. But to start with, I'll review the method that was presented in the other lesson that you saw. So we start by looking for two numbers that multiply to not just 4, but 2 times 4, which is 8. We also want those numbers to add to 9. Okay, so put a little bit of thought in that. What are those two numbers? The only numbers that multiply to 8 are 4 and 2 and 8 and 1. And 8 and 1 add to 9. Okay, the next trick, and it is a trick because this method is a trick to always get the right answer, is to divide those two numbers by 2. And the reason I'm dividing by 2 is from this number right here. Okay, now I'm going to redraw this, because I need to take my 8 halves and my 1 half and reduce them if they reduce. So 8 halves actually reduces to 4 over 1, and 1 half just stays as 1 half. Now that actually gives me the answer. Okay. The bottom number gives you the coefficient on x, and the other number gives you just the constant term. So x plus 4, and the other one is 2x plus 1. And of course, we can check and make sure that this did in fact work. Notice if I use FOIL to multiply this out, I should make sure that I get the right answer. X times 2x is 2x squared. X times 1 is 1x. Okay, 4 times 2x is 8x, and 4 times 1 is 4. And sure enough, x plus 8x gives you 9x. 2x squared plus 9x plus 4. So we know that we have, in fact, got the right answer. Now, I'd like to point out that you could definitely get this by guessing and checking. So if I imagine that I were to try this problem again, I notice a couple things when I factor. And that's that, first of all, there's really only one way to get a 2x squared, and that's 2x times x. I also notice that there's no negatives in this, so I can feel pretty confident that it's got to be a positive and a positive. There's only so many numbers that multiply to 4. You know, one example is 2 and 2. And that doesn't work though, because then you would go 2x squared plus 4x, you'd have an 8 here instead of a 9. So we know that that's not correct. The other possibility is maybe we have 4 and 1. That doesn't work either. 2x squared, we get plus 2x plus 4x, that's a 6 and not a 9. So 4 and 1 aren't correct. And really the only other possibility is 1 and 4, which is of course, you know, our correct answer right here. Just written the other way, that doesn't matter. Okay, let's try another one. Okay, here we have 3x squared, take away x minus 2. And this one I'm going to do a little differently, because this time I actually am going to try to do it just by guessing and checking. So I start by looking at it and say, is there anything I know for sure? Well, the first two numbers have to multiply to 3x squared. So I do know that it's got to be a 3x and an x. And I can be really confident about that. Now, these two numbers here, the last numbers, will have to multiply to -2. So I know one's got to be negative and one's got to be positive. Like one possibility is it's 1 and -2. Another possibility is it's -1 and +2. But of course, the order that I put these numbers in actually matters too. So I could have -2 and 1. Okay, or I could have 2 and -1. Those are really, there's really only 4 possibilities for what the rest of this would look like. So I could just start trying a few combinations here. You know, the first one being 3x plus 1 and x minus 2. Does that work? Let's just see. 3x times x. It's nice to be able to do FOIL in your head, by the way. 3x times x is 3x squared. I get a minus 6x and a plus 1. So like this one definitely is not going to work. It's not going to give you the right middle term. The next one is 3x minus 1 and x plus 2. Does that work? Okay, it gives me the right first term, 3x squared. It gives me the right last term, negative 2. The middle term would be 6x minus 1. Well, 6x minus 1 is 5x. That's not close either. You can see that the problem with these two is we're multiplying 3x by 2 and we're getting a 6, and that's not letting us get the right middle term. Next one, 3x minus 2 and x plus 1. Does that work? Let's just see, 3x squared plus 3x minus 2 is a 1. That doesn't work either. And we had some bad luck here, but this happens to be the correct one. You would get 3x squared minus 3x plus 2x is your minus 1x, and then 2 times negative 1, negative 1. So that's the correct answer. And you can get that from guessing and checking. And as you get better at FOIL and better at factoring, you might start to realize why some of these aren't going to work, and you might try this one sooner. But if you don't forget, you can absolutely use this method right here. Find two numbers that multiply to, in this case, negative 6. Okay, that's 3 times negative 2, and add to negative 1. And those numbers are negative 3 and positive 2. I then take those numbers and I divide them by 3, that number right there. Okay, I'd like to redraw this, make it a little bit neater. Negative 3 over 3 would reduce to negative 1 divided by 1. And this is already reduced 2/3. And then, of course, we get our answer. The bottom number gives us the x minus 1, and 3x plus 2. Notice, of course, I got the exact same answer. I just happened to write it a different way. So you can still use this method. Here we've got 2x squared plus 11x plus 12. Now, I can do this many different ways. I can guess and check. I can use the other method. I'll use the other method first. So we're looking for two numbers that multiply to 24, 2 times 12, and add to 11. And those numbers are 8 and 3. I then take 8 and 3 and I divide them by 2. Reduce those numbers, and they do reduce. 4 over 1, okay, because 8 and 2 both divide by 2, and 3 halves. And that's going to give me my answer. X plus 4, so that's my x and my 4. And 2x plus 3. And if you check that one, you'll find that that does, in fact, work. This one's not too hard to guess and check. I mean, there's a lot of possibilities for 12, but you do know it has to be a 2x and an x, so it's not too bad. There is another method that you might have learned in grade 10, so I'll show it to you really quickly, just in case you've learned it and you want to use it again. It's called decomposition. So if you've never seen decomposition, you might want to ignore this method, but if you have, and maybe you'd like to use it as well. It starts off very similar to the method above. You look for two numbers that multiply to 24 and add to 11. And by the way, if you can't find those numbers, including with this method here, it means that if those numbers don't exist, then it's not factorable. Of course they do, we just found them above, 8 and 3. And then with decomposition, you break up the 11x into 8x and 3x, like that. Okay, that's why it's called decomposition, because you decompose this middle term. Now this is valid. I mean, 8x plus 3x is 11, so it's okay to do that. And then the next trick is to actually common factor the first two terms. The greatest common factor is 2x. So you're left with 2x times x plus 4. And then you do the same thing with 3x plus 12. Even if the common factor is 1, you still factor it out. In this case, the common factor is 3. And you get x plus 4. Okay, and from there, you'll notice that you ended up with a common factor of x plus 4. And that's no coincidence. If you've chosen these numbers correctly, this will always happen. And you pull it out, and you're left with x plus 4 times 2x plus 3, which we know is the right answer. So if you've seen decomposition, there it is again, just to review it. If you're comfortable using that, you can. You've got 3 methods, basically. This method here, okay, with a little cross thing, decomposition, and then just guessing and checking. You could probably find other methods on YouTube or on the internet as well. They're all kind of variations of those things. I do want to show you this last one. And what's special about this is the fact that there's a negative sign out front. That does make things more difficult. The easiest way to handle it is to actually just factor it out. So what I'm doing here is actually just dividing everything by -1. And now I've got a negative here, but I'm going to factor what's left here using whatever method you like. Let's take a look at this again. So two numbers that multiply to -6, that's -3 times 2, and add to -5. Think about that one for a minute. This one throws students off a lot. It's actually not 3 and 2. Okay, there's no way to get the 3 and the 2 to multiply to -6 and add to -5. It just doesn't work. If they're -3 and -2, they would add to -5, but they multiply to +6. So you got to start thinking about 6 and 1. It's actually -6 and +1. Okay, take those two numbers and divide them. I mean, we can ignore this negative now because we're just factoring what's in the brackets here. Divide them by 2. Okay, and then I'll just redraw that, showing it what it looks like. And it reduces. We get a half, and we get -3 over 1. Okay, because 6 and 2 both divide by 2. And that gives us our answer of x minus 3 and 2x plus 1. Okay, if you're having trouble with that part, remember that 2x comes from here and the 1 here, so 2x plus 1, and then 1x. Okay, you can even write a 1 if you want, and the -3. And there you go. Now the negative stays out front. That's part of the factoring. Okay, so when you were to expand this, you would multiply these two sets of brackets using FOIL, and then you'd multiply everything by -1, and that's how you get back to -2x squared plus 5x plus 3. So that's the point I want to make with this example. Always take that negative and divide it out. And then we usually consider this to be factored like this with a negative out front, as opposed to having like a weird negative x term at the beginning. This is considered to be better anyways. Okay, I'll let you work on the factoring worksheet, and good luck with that. Thank you.